go.
Okay, so we have this system of equations, the same system we just solved here, and we found that x is 9. And of course then we could plug 9 into, let's say here, and we get negative 45 plus 41, right? Which gives negative 4, and that would be equal to negative y. I'm sorry, it wouldn't be negative, it'd be negative 4. I think I said negative 44. And that'd be equal to negative y, so y would be equal to 4, right? So we plug this into either equation, and we should get y equals 4. If we plug it into this one, we get negative 18 and 38. Don't tell me I did something else wrong. Probably. Okay, well, we'll see. I could have done my arithmetic wrong here, but 8 times 20 is 180. 9 times 20 is 180. 9 times 7 is 63. And 63 and 180 add up to 243. Okay, well, anyhow, solving by substitution. Okay, here we've solved it almost. We have to plug this in and get y, and that's a complete solution, okay? We're going to solve the same system by substitution. And for this, we plug well, first equation says that y equals this, right? We're going to plug negative 2/5 x plus 38/5. Into the second equation, plugging it in for y. If we do that, well, what we're doing is we're taking this expression and plugging it in for y here, which gives us
I got another class at freaking 2 o'clock.
negative 2/5 x plus 38/5 equals 5x minus 41, right? And then we add negative 5x to both sides, and we're going to get negative 2/5 x minus 5x on this side, and of course the 5x will go away on this side. Then we're going to subtract 38/5 from both sides, so they'll go away here, and we get negative 41 minus 38/5. Okay? And then we do this subtraction. Well, this is going to give us a familiar result. Well, let's multiply both sides by 5. We get negative 2x minus 25x equals negative 205 minus 38. So we get negative 27x equals negative 243, which is a lot like what we got here. So x, we got 27 into 243 here, right? That's what we're going to get here. And that gives us 9. And now, to find y, we plug x equals 9 all the way up here. For x, right? And that gives us the equation y equals negative 2/5 of 9 plus 38/5, right? And that's going to be negative 18 and 38. Gives us plus 20 over 5, which is 4, which is what I thought it was going to be when I looked over here. Okay? What I said a minute ago. So maybe I looked out and did the arithmetic correctly that time. Okay? Didn't mix anything up. Of course, 9, 4 is not our intersection point because I screwed up the slope, mixed up the two slopes with the different information. So, solution's 9, 4. Which is, of course, one of the given points, but that's because well, complicated, I'm not going to go there. Okay. Confuse the issue. Okay, so we understand now that if we have an expression for x or y in one equation, we can plug that expression into the other equation. Okay? And that eliminates the other variable. We can solve the equation because it's a simple linear equation. And we can plug that solution back into either one of our equations. But usually, if we use this equation, if we plug this into this equation, we'll plug this into the other equation. Okay? So that's one example of substitution. Of course, you're going to see a number of other examples in the open math assignment. Let's look at another example. Let's say that thing just beeped. I just heard it beep. Am I hallucinating again? Okay, well, maybe. Okay. Okay, here's another system. Let's say we got three x plus 7y equals 12. And 5x minus 4y equals negative 6. Now, you understand we can easily graph these two lines and find the point of intersection, right? Because we can easily find the intercepts. You know, if y equals 0, x equals 12 over 3, which is 4. If x equals 0, y equals 12 sevenths, well, that's a little bit of a pain, 1 and 5 sevenths, right? But it can be plotted. Then 5x minus 4y equals negative 6. Well, let's see. The x-intercept would be negative 6/5 because y would be 0, right? And the y-intercept would be negative 6 over negative 4, negative 3 halves, or positive 3 halves, because the y-intercept occurs when x equals 0, right? If you let x equal 0, you get negative 4y equals negative 6. And everybody should understand that because we've done a good bit of that last week. Okay? So you could plot these. And you could estimate the point of intersection. I'm actually going to go ahead and just do a quick plot. I'm going to try to be very accurate, but the y-intercept is going to be 4, so we'll say this is 4. The x-intercept is going to be a little less than 2, so we're going to say here. So let's say here's 2, here's the x-intercept, so here is the first equation. Second equation, the x-intercept is going to be negative 6/5, so that's going to be over here a little past negative 1. And the y-intercept is going to be 3 halves, which is going to be maybe about here. So now, here's where the two graphs intersect. Here's the x-coordinate, here's the y-coordinate. So the intersection point, and this is just a ballpark estimate, I'm going to say maybe it's 0.7 and that's maybe 2.8. Now let's see what it really is. See if I'm anywhere near close, okay? Probably kind of ballpark close, but probably not very close because it's a very crude graph. Okay, so I want to eliminate either X or Y. Well, watch what happens. I multiply the first equation by 4. Now, you don't know why I'm doing that unless you've done these before. But you'll agree, gives me this equation, right? And then I multiply the second equation, and the one circled one, this is 1. This is 2. Okay, equation 1, equation 2. So I multiply equation 2 by 7. I get 35x minus 28y equals 42. Now what's going to happen when I add these? One of the variables, either x or y, is going to go away, isn't it? Which variable is it? Do this if you think it's x, do this if you think it's y. Okay, which one goes away? Which one's left? Well, let's add them and see. 12 and 35 is 47, so I get 47x, right? 28 and negative 28 gives me what? Show me, give me a gesture with your hand that indicates the result. It's 0, right? Because 28 and negative 28 is 0. And 48 and 42 is 90. So we get 47x equals 90. Boy, my estimate was really kind of not great. We get x equals 90 over 47, which is approximately, it's a little over 2. I said 0.7. I'm suspecting I did some other bonehead thing, but anyhow, it's going to be 2 and 6/47, which is pretty close to 2 and 6/48, and 6/48 is an 8, so I'm going to say this is about 2.1. I'm guessing 2.10. Okay, so what do? We take this and plug it. Let's say this equation, which gives me 5 times 2.1 minus 4.4y equals negative 6, which gives me 10.5 minus 4y equals negative 6, which gives me negative 4y equals negative 16.5. And y equals negative 4.1, roughly. Plus 4.1. If the intercepts are what I say, man, okay. See what I did? Multiply by 7. 7 times negative 6 is negative 42. So that 90 should have been 6. So x equals 6 over 47, which is approximately 0.1. I estimated 0.7, but that indicates me a little bit. And I plug the 0.1 back in here, and really what I should have gotten should have been 5 times 0.1 minus 4y equals negative 6, which gives me, you can do the arithmetic, negative 4y equals negative 6.5, so that y is approximately 1.6. Now I estimated 2.8. I'll really be a little further over here, but this is much better than this, okay? I didn't think I was that far off. So you see how doing even a quick sketch using the intercepts allowed me to identify the fact that my solution was ridiculous. And I went back and looked carefully and saw I should have had another picture. Okay? So, when you solve these, sketch them, then do the arithmetic. Again, I just chose my multiples so that one of these variables would go away. Could have multiplied this by 5 and this by -3, and that would have worked as well, because I'd have 15x and -15x.